Sometimes you know when's best to just like keep cool. That's right. So at any rate, this represents like the different possible orbits. The different possible orbits that you might have, and I want to explain why you would need a polar orbit. Now, first of all, something like this isn't even an orbit because the center of this has to be at the center of the moon, like a great circle. So something like that wouldn't even be an orbit. You could have an orbit like this, but the problem is the white light's where it's looking down. It's not even going to see any of that stuff. You could have a tilted orbit, but even now, when the moon's going around, it gets lots of the moon, but it never gets over there. If you want to map the entire moon's surface, you have to go over the North Pole and over the South Pole. Now you can see how eventually everything gets mapped. So that's why they use a polar orbit to do that. And the camera itself is like this slit that looks down at the moon. The camera on the lamp camera on the Lunar Reconnaissance Orbiter is actually a slit which goes over the surface of the moon. Here's what the moon looks like in normal light. That's what the moon looks like in normal light over there. But because ultraviolet light from the sky hits the moon, where it reflects is dry, where it is absorbed, there's a possibility that there's water ice. And so this camera is like a slit that moves with the spacecraft. And can you see the places that are dark? Those are possible places for water ice. They can only happen at the North Pole of the moon, and they can only happen in a deep crater at the north or south, I should say, poles of the moon. And that's what it's looked. And then it's the Lunar Reconnaissance Orbiter. When you put all those pieces together, it would look like that. It's the Lunar Reconnaissance Orbiter, and it is the lamp camera is one instrument that's on the Lunar Reconnaissance Orbiter. It's supposed to go up in February, is what they're saying. Pretty good. Is my hair okay?